An operating system provides a way for users to interact with a computer. You've probably used operating systems such as Windows, macOS, iOS, or Android. You'll notice that different operating systems do the same things, but they do them in different ways. Unix is an operating system that dates back to the late 1960s, when researchers at AT&T Bell Laboratories created it. Unix has several key components. It's multi-user, which means that more than one person can use it at the same time. It's multitasking, which means that it can run multiple programs at the same time. It has a hierarchical file system, and it uses environment variables to allow for customization. It also provides a set of useful utility programs to perform common tasks. Initially, Unix came with the source code, allowing universities and researchers to modify it. These modifications were known as distributions, and the community used them to improve Unix. BSD, also known as Berkeley Software Distribution, was a widespread distribution created by the Computer Systems Research Group at the University of California, Berkeley. Commercial distributions began appearing in the early 1980s. For example, Microsoft created Xenix, Sun Microsystems created SunOS and Solaris, Hewlett-Packard created HPUX, Silicon Graphics created IRIX, and IBM created AIX. By the early 1990s, open-source versions of Unix, such as 386BSD, Minix, and Linux began to appear. In the early 2000s, Apple released OS X, now known as macOS, another version of Unix. Today, there are several Unix distributions available. Most Unix distributions are available via ISO files. You can write an ISO file to a USB flash drive, which can then be used to boot the computer into the installer for the operating system. Fedora Media Writer is an easy way to write an ISO file to a USB flash drive. Download the Fedora Media Writer and install it. Fedora is a free Linux distribution. The Fedora Media Writer allows you to download a Fedora distribution easily. The Workstation version provides a graphical user interface similar to Windows or Mac OS. You can select from various Fedora versions and hardware architectures. Finally, you can select the USB flash drive to use. Once you've made all your selections, the ISO file will begin downloading and writing to the USB flash drive. Once you have a distribution on a USB flash drive, you can boot the computer and install the operating system. Depending on your computer, you might have to press a key such as F2 or F10 to select the boot device. In the worst case, you'll have to enter the BIOS and configure the boot device. When the computer starts up, a boot menu will appear. You should select Test this media and Start. Once the installer appears, select Install to hard drive. Select the language you wish to use. Configure the keyboard as well as the date and time as needed. You probably will not have enough free storage space to install Fedora. Fedora requires at least 20 gigabytes of storage space, while the recommendation is at least 40 gigabytes. If you plan on using Fedora a lot, you can increase the size as desired. You will need to shrink the Windows partition, which could be NTFS, FAT, or FAT32, by the desired amount. Shrinking the Windows partition should not destroy your data, but you should back up the system before you begin. The installation will probably take a little bit of time. Once Fedora has been installed, you'll need to shut down your computer, remove the USB flash drive, and restart the computer. Use the System menu at the top right to shut the computer down. When the computer boots up, you should be presented with a menu that allows you to boot into Fedora or Windows. The up and down arrows allow you to select the operating system to boot. Pressing Enter will boot the computer with the selected operating system. You will need to set up Fedora the first time it boots. You can choose if you want to enable location services and automatic problem reporting. You should enable third-party repositories, allowing your video card to work better. You can set up any online accounts that you want. Every user in the system requires a unique username. A password is required. You'll want to make sure that Windows still boots up and is usable. Originally, Unix predated most graphical user interfaces, leaving the console as the primary way for users to interact with the system. The keyboard, screen, and mouse are all part of the console. The terminal is a piece of software that controls the different parts of the console. Today, the terminal is typically displayed in a window. To start a terminal in Fedora, you can show the applications and select the terminal icon. To view the applications, select the Activities area or press Start on the keyboard to show the dashboard. You could click on the terminal to run it, but you'll be using it fairly often, so you may want to pin it to the dashboard for easy access. Right-mouse click on the terminal icon and select Pin to Dash. Press the Escape key to hide the applications, and then press Escape again to hide the dashboard. Now you can show the dashboard and click on the terminal to launch it. To close the terminal, type Exit. Each terminal runs a program called a shell. The shell is responsible for taking what is typed by the user and interpreting it. For example, if the user types in the name of a program, the shell is responsible for locating the program, running it, and displaying the results on the screen. There are several shells to choose from, such as bash, tc shell, corn shell, z shell, and fish. Unix comes with a large number of standard programs. Type the name of a program to run it. One important utility program is man, which stands for manual. You can use the man utility to determine what a program does or what command line arguments it takes. Here you can see all the information about the man utility itself. To exit out of man, press Q. The clear utility clears the screen. To see what all the clear utility can do, run man clear. There are three flags, T, V, and X. T says you usually don't have to use it. V reports the version of ncurses, a library for doing terminal-based graphics. X does not clear the scroll back buffer. Unix has a special user, root, also known as the superuser, who acts as the machine administrator. The root account has access to all the files and commands on the machine. Sometimes a regular user will need to run a command that requires elevated permissions. That means that the command is restricted to another user, typically root. It would be very insecure to give the root account password to everyone who needs to run a command that requires elevated permissions. Fortunately, there's a program called sudo, or substitute user do. Sudo allows a user to run a command as a different user, including root. By default, when you run sudo, the substitute user is root. If you run sudo clear, it will ask for your password, not the password of the substitute user. The sudo command verifies that you have access to run commands as the other user and uses your password to determine that you are the person running the command. Never tell anybody else your password. Sometimes you want to run many commands as another user, and it may be inconvenient to run sudo for each command. To create an interactive session, pass -i to sudo, which logs you in as a substitute user. Sudo didn't prompt me for my password because I ran it recently, and it waits a few minutes before asking for your password again. Now you're in as the root user. You can run whatever commands you want. After running the commands, you can exit the other user's account. Your shell is now back to normal. Keeping the system up to date ensures that it has the latest bug and security fixes. Most distributions have a lot of open source components, with many developers working on them. With many active developers making changes, updates are probably reasonably frequent. Your system may have new updates every day. The DNF Package Manager is a utility that keeps Fedora up to date. DNF is an administrative utility and requires sudo to run. Type sudo dnf update, which will download a list of available updates for your machine. Selecting yes will download and install the updates. When the updates have finished downloading, DNF installs them. DNF can also add new programs to the system. The GNOME Tweaks utility adds ways to customize the Fedora desktop. To install GNOME Tweaks, run sudo dnf install GNOME Tweaks. Once installed, you can run GNOME Tweaks by going to Utilities under Applications. Select Window title bars. Turn on Minimize and Maximize. You can now minimize and maximize any window. Sometimes you'll want to turn your computer off. Maybe you want to shut it down for the night. Perhaps you want to use a different operating system, or maybe you've just updated the operating system and want to be sure that it's running the latest fixes. The shutdown and reboot utilities are perfect for these situations. By default, shutdown turns the computer off. Passing the reboot flag will reboot the computer instead. By default, reboot will restart the computer. Passing the power off flag will shut the computer down instead. The shutdown utility will schedule a shutdown for the future. You can cancel the shutdown by passing -c. If you want to shut the computer down immediately, pass the time now. If you run the reboot utility, it will happen right away. The file system is one of the most powerful features of Unix. It's a single-rooted system, meaning that there's one directory, called root, with all the other directories underneath it. The file system is hierarchical, which means that it can have directories inside of directories. You can type pwd to see the path of the current directory. Depending on your distribution, home may be called something else, such as /user/home. The slash character separates directories from one another. Slash is the root directory. Home is a subdirectory of the root directory. Pat is a subdirectory of /home. The path is home pat. Note that the name of your home directory is the same as your login name from setting up your account. pwd always reports the current path, also known as the current working directory. cd/ goes to the root directory. cd tilde goes back to the home directory. The ls utility lists the entries in a directory. ls-l provides the same list, but with more information. ls-al provides the same list, but includes hidden files. Any file or directory that starts with a dot is hidden. These are typically configuration files, which you normally do not want to see. The makedir utility creates a new directory. If you want to create a path of subdirectories, you can. However, it will fail if any intermediate directories do not exist. Rather than typing a command in again, use the up and down arrow keys. Add the -p flag to have makedir create all the directories in the path. cd can also take a path instead of just a directory name. You can use the tab key to autocomplete part of the path rather than typing the full directory name. pwd now shows you're in the home, pat, foo, bar, car, star directory. To go to the parent directory, type cd ... Dot is used to create a path relative to the current directory. cd with no arguments changes to the home directory. The rm utility deletes a directory or path. The -rf tells rm to delete the foo directory and its contents recursively, without prompting. Deleting a directory can be dangerous. If you delete something with rm, it is gone forever. No recycle bin exists. Many Unix shells support the pushd and popd commands. Pushd and popd work with a directory stack. Pushd adds a directory to the stack, and popd removes it. These commands are helpful for temporarily moving to a new directory and then returning to the original path. The /etc directory contains several system configuration files. Type popd to return to where you were. There are a few ways to create a file. The touch utility will update a file modification time to the current time. If the file doesn't exist, touch will create an empty file. If you wait a minute for the time to change and rerun touch, you will see that the time changes on the file. Another simple way to create a file is with the echo utility. The echo utility prints out to the console whatever you pass it as an argument. You can use IO redirection to have echo, or any program, print to a file instead of the screen. ls*.txt lists all the files that end in .txt. The star, or asterisk, is called a wildcard. You can use a wildcard for any part of the file name. You can also use a question mark for a single character wildcard. Notice that foo.txt, created by touch, has 0 bytes, but bar.txt has 6, 5 bytes for hello, and 1 for the new line at the end of the file. You can remove files with the rm command. rm can take several names to delete. One of the most powerful features of Unix is its ability to manipulate files. An editor is an easy way to create and modify files. Unix has several different editors, and you're free to use any of them that you want. Nano is a relatively simple text editor. Nano opens a file if it exists, or it creates a new file. You can type in text, and navigate with the arrow keys. To save a file, press Ctrl-O. To exit Nano, press Ctrl-X. You can use Ctrl-K to cut a line, and Ctrl-U to paste it. To see the current cursor location, press Ctrl-C. You can see the current line, column, and offset from the start of the file. Unix provides several utilities to display files. The cat utility is similar to echo. Use Ctrl-D to exit. Cat can create a file with IO redirection. Cat can also display the contents of a file. IO redirection either overwrites or appends to a file. Using a single redirect will overwrite any information already in the file. A double redirect will append the input to the file. You can also use IO redirection to have a program read from a file instead of the keyboard. Create a file with the alphabet. The NL utility numbers each line of a file. You can see that there are 26 lines in the file. Edit the file to have some blank lines. Number the file. You'll see that the blank lines do not get numbers. To number all of the lines, pass -BA. You'll notice that the file is too big to fit on the screen. A pager utility allows you to view part of a file. The more utility displays one page at a time. To get to the next page, press the space key. To exit more, press the Q key. The less utility is similar to more, but you can use the up and down arrows to go back and forth in the file. To exit less, press the Q key. Anything in the file system, such as a file or directory, is called a file system entry. File system entries can be listed, copied, moved, and deleted. To move a file system entry, use the MV utility. Now you can see that the directory is named bar. Now you can see that the foo.txt file is named bar.txt. The cp utility copies a file system entry. For files, cp works similar to mv. Provide the old name and the new name. For directories, cp requires the -r flag so that it can recursively copy the directory contents. Sometimes you'll want to run the same sequence of commands repeatedly. Entering commands can be tedious and error-prone. A shell script automates a set of commands. Shell scripts can range from simple commands to very complex logic. Typically, a shell script ends in the characters .sh. You can type in any commands, The easiest way to run a shell script is to run a shell and pass the name of the script to run. Shell scripts can take command line arguments. To access the arguments, use $0 through $9. Now run the shell script and pass the arguments. Notice that it printed the shell script name, foo.sh, and the hello argument, but not the world argument. $0 is the name of the shell script. $1 is the first argument. To see world, you need to put quotes around the arguments. The quotation marks turn hello world into one argument. Alternatively, you could echo $2 in the shell script. Shell scripts can contain variables. Create a variable called message. To use message, prefix it with a $. In Unix, every file system entry has permissions. ls-l shows the permissions. There are 3 characters, R, W, and X. R means read, W means write, and X means execute. There are also 3 sections of RWX, user, group, and other. The user is the owner of the entry. A group is a collection of users. Other is any user that is not the owner and not in the group. Each file system entry has read, write, and execute permissions for user, group, and other. You can see that the foo.sh file has a user of Pat and a group of Pat. The user Pat can read and write the file, but not execute it. Users in the Pat group can read and write a file, but not execute it. Anyone else can read the file, but not write or execute it. The chmod utility changes the permissions. Now the user can read, write, and execute the shell script. Chmod can also remove permissions. The shell script can now be run just by typing its path. The shell script will run in the default shell, which may not be the one you want. To force a shell script to run in a specific shell, add a shebang at the top of the file. A shebang is a comment telling the shell what shell to run the shell script in. That might be a bit confusing. Remember that each terminal has a shell. The shell is responsible for finding and running each program. A shell script is not run in the current shell. Instead, the current shell runs the shell script in a new shell. If the shebang is not present, the shell runs the shell script in the default shell. Use the which utility to find the path of a program. This system's path to the bash shell is user bin bash. Unfortunately, not all systems have the bash program in the same directory structure. The env utility finds and runs a program. Now that you know how to specify the path to the shell, it's time to add the shebang to the shell script. You can run foo.sh and be sure that it's running in the bash shell. A typical Unix system has several environment variables. These variables generally alter the behavior of the system. Use the env utility to see the current environment variables. There are many of them. Being able to page through them would be nice. A pipe can send the output of env to the input for less. You can now scroll through the environment variables. For example, you can see that I'm using the GNOME desktop and that the home directory is /home/pat. Programs can access environment variables, enabling them to be more dynamic. One of the most critical environment variables in Unix is path. To quickly see the value of the path variable, pipe env to grep. Only the environment variables that contain the word path are shown. Grep is a handy utility to help you find specific text. Path is a colon-separated list of directory paths. When you type in the name of a program, the shell takes the name of the program and searches through each of the directories in the path variable until the program is found. The shell runs the program as soon as it is found. The path contains home pat.local bin, home pat bin, user local bin, user local sbin, user bin, and user sbin. When you type in a program name, such as clear, the shell looks for /home/pat/.local/bin/clear, but it doesn't find it. Next it looks for home pat bin clear, doesn't find it. User local bin clear, doesn't find it. User local sbin clear, doesn't find it. User bin clear, doesn't find it. Finally, it looks in user sbin clear and doesn't find it. It does find clear somewhere in there. It finds it in user bin. As soon as /user/bin/clear is found, the shell stops searching and it doesn't bother looking at user sbin. The bash shell has several files that allows the system and the user to provide different configurations. etc profile sets up the environment for all users on the system. Some other shells also read etc profile, so the etc bashrc file contains system-wide bash-specific configurations. Users can have several configuration files in their home directory, allowing them to customize their environment. .bash profile is the recommended file to store bash settings. .bash login runs whenever the user first logs in. .profile is similar to etc profile in that other shells will read it. .bashrc is similar to etc bashrc in that only bash will read it. Bash logout runs whenever the user logs out. None of these files have to exist. Bash will ignore any missing files. Create a directory called scripts. Create a new shell script. Add the execute permission. Run the script. If you type the name of the shell script, the shell can't find it. That's because the scripts directory does not exist on path. Edit the bashrc file. Append the scripts directory to the path. Check the path variable. The scripts directory is still not in the path. To update path, you can exit the terminal and start a new one, or use the source utility to rerun the bashrc file in the current shell. The script directory is now on the path. Type in the script name, and the shell will run it. Sometimes it's inconvenient to have multiple terminal windows open simultaneously. A terminal multiplexer, such as the tmux utility, can create several virtual panes inside one terminal window. To create a new pane to the right, press Ctrl-B, followed by the % key. To create a new pane below, press Ctrl-B, followed by the double quote key. To switch between panes, use Ctrl-B and the arrow keys. To exit a pane, type exit. Now you can edit a shell script in one pane and run it in the other. Save your changes, but don't exit the file. Switch panes. Set the permissions and run the shell script. Switch back to the other pane. Edit the script to display the first argument. Save your changes. Switch back to the other pane. Run the script. To exit tmux, exit all the panes.